4.9. The atomic mass. Well, we just learned that there are isotopes, right? And they differ in their mass number, so they're going to differ in their masses as well. And if we look at the periodic table, maybe there's a picture coming up. No, that would be too convenient. If we look at the periodic table, I'll draw you a little picture. So if we look at, we were just talking about chlorine. Chlorine is element 17, right? Yeah, 17. And there's a number underneath the symbol, and that is 35.45. And that is the average mass of chlorine atoms. There's two different kinds. There's chlorine 35 and there's chlorine 37. And we learned a little bit about atomic mass units. They're very close to the mass of a proton and a neutron. And so chlorine 37 has a mass of 36.97. If you rounded that, it would be 37 atomic mass units. Chlorine 35 has a mass of 34.97 atomic mass units. So you've got these two very similar things, but they're slightly different in mass. If you have a big sample of them, you don't really care about the mass of each individual one. You care about the average mass, right? Because you're dealing with a whole bunch of them at one time. You never deal with just like 2 atoms at a time. They're way too small to see, so how could you do anything with them? We're always dealing with large groups, and so we're concerned with the average mass of an atom of chlorine. Well, so we're going to figure this out. One way to do an average is to take the mass of each individual thing and add it together and divide by the total number, right? So let's do that with 6 times 10 to the third atoms. That would take you several lifetimes to add that many numbers into your calculator, right? That's not going to happen. So what we do is we use what's called a weighted average. So scientists have measured and studied and determined that 75.7% of naturally occurring chlorine is chlorine 35, and it has this mass. 24.23% is chlorine 37. Instead of adding each of them up and dividing by the total number, we can use the percentage to calculate the average. And so the way we do this is we take the percentage and we divide by 100 to make it in decimal form. So 75.77 becomes 0.7577. And we multiply that by the mass of that atom, isotope. And then we're going to add the other percentage divided by 100 times the mass of that one. And when we do the math, we come up with 35.45. That's the average mass of a chlorine atom. Now, there is no chlorine atom that weighs exactly that mass, but that's the average. Any questions? So another way to write this out for you, here's the pattern. The atomic mass is going to be the fraction of the first isotope times its mass, plus the fraction of the second isotope times its mass, plus the fraction of the third isotope times its mass, and you would keep going like that depending on how many isotopes there are. The fractions are the percent abundances converted to their decimal values. So 60% is equivalent to 0.60. It's 60 out of 100, right? Percent means per 100. So 60% means 60 things per 100 things. Well, if you take 60 and divide by 100, you get 0.60. Okay, so that's how we're doing that. let's do an example. Magnesium has 3 naturally occurring isotopes. These are the masses and the natural abundances, 78.99%, 10%, and 11.10%. Calculate the atomic mass of magnesium. So we're going to take the percentage of the first one and convert it to a fraction. So that's 0.7899. And we're going to multiply that by the mass of that one. These are listed in order. So that one's going to be 23.99 atomic mass units. And then we're going to add the second percent converted to a decimal, a fraction, times its mass, plus the third one, 0.1110, times its mass, 25.98 atomic mass units. And I forget to get my calculator out. Got too many calculators in my bag. So we've got 0.7899 times 23.99 plus 0.1000 times 24.99 plus 0.1110 times 25.98 equals. And so this is showing me 24.332481. In a situation like this, there's a kind of a shortcut for significant figures. These have 4 significant figures, and these have 4, and so we're just going to go with 4, and it works out, when you combine the rules, it works out just fine. So 24.33 atomic mass units is the average. This sort of a calculation, I think all calculators will understand if you just do it from left to right, it'll get the order of operations correct. Check your work. An average has to be between the highest and lowest value. You can't take the average of 2 and 3 and get 7, right? Because the average is in the middle. So it has to be between the highest and lowest. So that's an easy check. Is it between the highest and lowest? Yes, it is. We probably did it correctly. This one we can also check on the periodic table because the mass of magnesium is on the periodic table. Any questions? And wow, there's the end of chapter 4. So the review, this is the different things we talked about. And then chemical skills, these are the things you should be able to do. And those things will probably show up on the exam.